Now here I have my Animator window next to my game window. I did this so we can monitor what's happening in the Animator during game time. So let's just start it up. And what's really cool is that we can track each state and its progress live. So I can see here, this idle animation lasts about 17 seconds. We're about halfway through. And I just want to highlight what happens at the end of this animation. Well, what happens is that it's done and it doesn't loop. We're not changing state. We're pretty much at the end here. Nothing is going to change. Here's a closer look. Everything is static. Especially for an idle animation, this really isn't appropriate. So imagine a non-playable character. We want it to repeat its idle animation until a certain condition is met, like when it interacts with a playable character, for example. So we just want to keep looping this idle animation nonstop. How do we do that? Well, it is possible to modify the animator here to have the idle animation just cycle back to itself. But the easiest way to do so is just to go on the animation clip itself, so this animation file, go in the animation panel, and just check this loop time option and click on apply. Now let's do the same experiment. We'll wait 17 seconds. And there you have it. We can see that the animation looped. So now we're still in the idle animation, but at least the animation keeps on repeating itself. Here's a closer look. Okay, so we noticed that the idle animation is quite slow, and I'm going to try and not waste your time so much. Let's double it to not 23, but to 2, okay? So that means that you're going to see the progress bar here progressing twice as fast. And we're not changing the source animation. We're not changing the actual player at idle file. We're just taking this particular animation controller that we're building in the Animator window right now, and we're saying that this state will run twice as fast. So we could have different animation controllers that use the same idle animation, but that play it back at different speeds. So that's good to know. Okay, let's get into some cool stuff right now. So let's transition from idle to walking. Here in this walking state, I've already added the walking animation as such. I'm going to keep it at the normal original 1 speed. And to create a transition from one state to the other, I'm just going to start at this node, right click, make transition, and then just bring my mouse and click on this walking state. So we end up with this directional graph representation, which is pretty cool. So we can see that from idle, we can transition to walking, but we can't go from walking to idle. It's unidirectional. We'll create a cycle here in a couple seconds, but let's just test this out. And let's try and guess what will happen at the end of this idle animation. Will it loop as before, or are we going to change states? All right, so we went to the walking animation. Cool. And why is this walking animation looping? Well, behind your backs, I actually went here and I checked loop time and applied that modification. So that's why we got this looping. Now, what happens if I create this sort of transition? Well, you can probably already guess. We're going to go from idle to walk, back to idle to walk in an infinite cycle. But that's not really what I want to do right now. So I'm just going to delete this transition by clicking on this edge between the two nodes. And yeah, you can see in the inspector, there's some funky stuff going on. We'll have fun with this later on when we try and work and tweak our transitions. But I'm just going to delete it for now by pressing the delete key on my keyboard. Okay, so let's add some interactivity. Let's say that the transition will happen not automatically, but only once the player actually starts, well, moving the character. So we're going to make this a bit more interactive by scripting this sort of behavior. Now, I'm just going to go back here and show you what we kind of want to do directly by manipulating the game object in the scene. So I'm going to take the player here, and now we see that we're looping our animation, and we're just going to want to make it move forward. So we're going to take its forward vector, so this blue vector, which is its local z-axis, and we're just going to move it forward through time. Obviously, if we move it too fast, we really get that floating effect that I was talking about earlier. So the displacement isn't matching the animation. But if we go at something like this speed, it's maybe not too bad. Obviously, it will be much smoother when I program it rather than doing it by hand here in the scene. So we need to talk about parameters here. Parameters are basically variables that we can use in our state machine. So I'm going to click on parameters here. We have an empty list for now. Let's click on the plus here, and we see 4 types of parameters, 4 variable types. Trigger is basically a special case of Boolean, so let's not think about that too much for now. And well, float and int are pretty self-explanatory. So these variables can be used as, well, data in conditions. And these conditions can dictate if we can go from one state to the next, for example. Let's say that we can only go from idle to walking if a certain Boolean is set to true. Let's say that we can only go from walking to running if a certain float variable is greater than a certain value. So let's say we have a float variable that represents our current speed. Well, until we hit a certain speed, we can't go from walking to running. That's just a really basic example. But let's start with the simplest, a Boolean variable or Boolean parameter. So I'm going to call this isWalking, running it in Pascal case, which is standard for C#. All right. Now let's see what we can do with this. So I'm going to click on the transition from idle to walking. And we can see a lot of funky stuff, as I said previously, but let's just ignore this. And let's click here to give an appropriate name for our animation. So let's just call this transition start walking. Sorry, I said animation, I meant transition. Let's name the transition. So this is our start walking transition. I'm writing it in Pascal case again, so no capitalization on the first letter of the first word, but I will capitalize the first letter of every subsequent word. Now, here we have conditions. So these are the conditions that need to be met for this transition to occur, the start walking transition to occur. So I'm going to click on plus here, and since I only have one parameter, that's what's selected. But if I click here in the drop down, I can select all the parameters that I've created. Again, I only have one. And here my condition is true or false, since this parameter is a Boolean type. So now we're saying that you can only go from idle to walking if your animation has this isWalking parameter set to true. And currently it's false. Let's look at this. Okay, we're in idle. We can see that it's progressing. Now will it switch? No, it won't, because our isWalking here is false. When it's unchecked in this window, that means it's false. So let's change that. I'm going to set it to true. And there we go. Now we get to progress to the next state, and we're walking. Now hold up just a minute. What's up here? We can see that player is, well, walking, but not Michelle. But they both share the same player animation controller, right? We can see here player animator is using the player animation controller, and Michelle, well, the same thing. So actually, when it comes to parameters, if I click on player here, it has its own isWalking parameter. So they both use the same animator, the same graph here, but they each have their own local copies of these parameters, of these variables. So they're not like static variables in another way to put it. So that's pretty cool, actually. So now I can actually set Michelle to isWalking, and we'll see that, okay, great, Michelle is now walking. So this is really cool because let's say we want to have a two-player game. We want them to both use the same graph here, basically, but we don't want to make the second player start walking when the first player starts walking. So that's why we have these local copies of these parameters. Imagine if we could take this variable and just modify its state, not manually as I was doing here, but dynamically during playtime with code. Well, that's exactly what we're going to do. You don't need to imagine for very long. So we're going to create a script that gets a reference to this parameter, and we can change its state from true or false, depending on certain conditions, like if we press the W key to move forward, for example. And just changing that variable state will actually change what happens here in the animator. So it will allow us to transition from the idle to walking animation, for example. So let's try that out. Okay, so let's finally get programming. I've created this new script called Animation Test, and I'm just going to bring it into my scripts folder to help organize my project and keep it nice and clean. If you don't recall how to create a script, there are multiple ways. One way is just to right-click, create C# script and give it a name. Or I want to add this on my player, so I just did add component and I wrote down a name. I clicked on new script and then clicked on create and add. Now I actually did something that I didn't want to do here. I added it on this particular instance of player, but not on the prefab itself. So I'm just going to fix that. I'm going to open up my player prefab and I'm going to give it this new script. Great. And the script is completely empty. Well, it has start and update in it as any new script, but there's nothing else going on. So we can see here. I'll just open it up by double clicking on it. There we go, start and update. Now, the first thing we're going to want to do is get a reference to our animator component. So this script will be on player. We could also put on Michelle later on if we wanted to. And we want to get a reference to this animator component. So recall that we can do something like this. So this animator component is of type animator. I'm going to name it animator equals get component. Here we're going to parameterize the function call with a type, so animator. And there you go. Now this script has one flaw, as you might see. What happens if we put the script on a game object that does not have on it an animator component? Well, this will return null, and potentially if we start using this animator variable for something, we'll get null exceptions. So let's just cover our backs here by adding this required component attribute to our class. So we require type of animator. Great. So if you don't recall, what this does is it will force any game object that has an animation test component to also have this animator component. So it's a sort of a dependency information. So we're saying that animation test depends on the fact that the game object also has an animator component. So for example, if I take Michelle here and, or actually let's just take a new game object. I'm going to give it my animation test. It will automatically add the dependencies. If I try and remove it, can't remove animator because animation test depends on it. So that's pretty cool. All right, let's keep going. So now I know, even if I don't run this script, that animator is not null. I don't have to do any other null checks here with ifs that are heavy. I don't even need to use asserts and stuff like that. We know that it's not null, so that's great. Now, what do we want to do with this reference to the animator component on our game objects? So in this particular case, remember that it's on the player game object. Well, what we want to do is take the animator dot, and now we can set bool. And let's look at the tooltip here. So it takes either an int ID or a string name. So we have two overloads for the set bool function. I'm going to use the string variant, and we're just going to put our is walking string in here. And then we give it a Boolean value. So let's set it to true. Okay. So what this does is that, yes, we get a reference to this particular animator on our player game object. And we're going to set this parameter is walking for the player to true. So let's just start this up. Let's look at the animator for player, and there you go. It's set to true, and we're going to see idle to walking. Great. So that's pretty cool, but pretty useless for now. We want something more interactive, so let's keep going. Just a quick note, however. What happens if I put this script on a game object that, yes, obviously has an animator because it requires an animator component, but that animator does not have an isWalking parameter? Well, we're going to get something undesirable, to say at least. So that's one issue. Another issue is that we have a hard-coded string in here, and that's not cool. It's okay for quick tutorials and maybe a lab here and there, but if you're actually working on a full-scale game, hard-coded strings are to be avoided for obvious reasons. For example, what happens if we decide to change this isWalking to a different name? It can happen. Multiple people can be working on the project. Some people can be working purely in code, and other people, like game designers that are less proficient in programming, they can just be working on the graphical user interface for setting up the variables that the programmers will use afterwards in their code. So somebody can create a typo here or change the name, forget to tell a programmer, the code doesn't get updated automatically. Obviously, if I delete this and create a new one, and I call it isWalk instead, well, this code won't work anymore. So that's one big flaw with hard-coded strings, not just for animation, the animator, but for a bunch of different cases. Let's keep it here for now, and soon enough we'll use something a bit more versatile. So I'm also going to change this start to awake. And I'm just going to remove this line from here. Now, why did I change start to awake? I guess you can call it personal preference. If you're unaware of the differences between awake and start, we can maybe go over that at a later time. But I use awake for self setup. So I will get any component that I can. I will just set up the initial state of the component. And I will use start to actually start doing something, to start calling some functions. And really, well, I don't know how to put this, but I'm going to just start my processes. In awake, I'm not really starting anything. I'm not getting anything done. I'm just setting up the internal state of this component that's going to get instantiated once I run the game. So I'm going to go get the component here. And I set up this variable. And actually talking about state, so I'm not going to make this a local variable. I'm going to want to use this animator in my update function pretty much very soon. So I'm just going to make this animator as a declaration up top here. I'm going to keep it private. So recall that in C# everything is private as default, but I just like to have it explicitly written for some reason. And that's actually what the writer defaults to. So the writer IDE will actually put private in front of your member fields. Anyways, why is it private and not public? Well, no client code should be able to switch this animator to something else. I don't want another script to come here and interfere and set the animator to null, for example. And I don't want to be able to change this variable through the inspector. So I don't want to come here and have this member field exposed and modifiable through the editor. It's just not necessary. So, you know, good encapsulation and whatnot. Remember your object-oriented programming good practices. Now, I'm going to use this animator that we know has a non-null value in our update function. So we're eventually going to take this animator and, okay, set bool is walking. We're going to end up setting it to true, but only based on a certain condition. And this condition will be if the key press of W is performed. So if input dot get key down, I'm going to put the key code dot W. So this is a value from the key code enumeration. So if that's pressed, let's switch the state to walking. I'm just going to quickly save this. Okay. And now let's go back here. Let's monitor the state of is walking for player. So I'm not pressing W yet. I'm going to press it now by going back into the game and pressing it OK. And there we go. We saw this went to true and we switched from idle to walking. Now my camera moved a bit because remember that I have this simple camera controller. So I'm just going to get rid of that. And let's do the experiment one more time here. And what I'm going to do is just pop this back out again. Okay, I'm going to press W. This goes true, but we remain in our idle animation because the transition wasn't called upon yet. The transition only happens, remember, at the end of the state. And it also only happens if is walking is set to true. So it's like if we have two conditions actually for going from idle to walking. First of all, idle needs to be complete and is walking needs to be true. So I just clicked around here and I reset some of the data. I'm going to press W again. We see this is true. This is going to complete and we're going to move on to the next state. And now this player character is in its walking state. All right, so I wasn't really satisfied with how I recorded this section. I'm just going to have a second attempt right now. This is a bit further down the line in the lab, so you might see a few differences here and there, but that should not be an issue. So I want to go back to what we were doing, where we noticed that is walking can be checked, but the transition is not happening once it goes true. It will happen once this idle animation, this idle state is pretty much complete. Let's look a bit more into that. You might have a different value here. I just cleaned it up a bit. But if we go into settings, exit time, this is actually how much progress of the animation needs to be complete before we can actually go to the next state, which is walking in this case. So it's not actually 100%, it's something around 98.5. If I put it at 100%, then the idle animation needs to be 100% complete before allowing the transition to occur. And we also see that there's this transition duration in seconds. So even when we have that transition happening, it's not instantaneous. There's a bit of time happening in between to allow a few things that we might look into later. So let's say I put this in 0.5. So now this is gonna play, it's gonna loop since is walking isn't checked. I'm gonna check it now and take a look what's gonna happen at this point where my mouse is at. All right, so at 50% of progress, we start a transition which lasts a quarter of a second, and then we hit our walking state. Let's actually play around with this transition duration. Let's make it like an entire 2 seconds. And notice what happens here. So we can see that, actually before looking here, let's just look at the result. I'm going to check this. At 50%, we're going to change. And we start the progress. So that took more time. Let's make it even more exaggerated. I'm going to increase that transition time to 5 seconds. Oops, I forgot to check this. Okay, let's have a second go around. So this is taking time. The animation is playing. Let's look at the left. So we have some slow walk animation happening during the transition. So there's some walking happening without fully being in the walking state, without even actually being in the walking state. So long transitions can be cool because they allow this kind of stuff. Like, see here, this tracks the blending of both animations during the transition. So we can see that at this point where my mouse is at, which is pretty much the 50% mark, right? So let's say is walking is set to true. We have to complete, as stated here, 50% of the animation before we start our transition. So this blue section is our transition. And we get less and less idle animation and more walking animation. We can see that we're actually fitting like 5 cycles of walking in here. Once this blue area is 100% in the walking animation, that's the point like here at the end of this blue rectangle where we are at our walking state. We've finally finished our transition and we've reached the walking state. So at that point, we're only seeing walking animation and not this blend of idle and walking. So how does Unity actually blend idle and walking? Well, it just blends the transformations in both animations in an intelligent way using different interpolation techniques, which we really don't need to go into. We just need to understand that this is happening. And it's actually pretty great because let's take another look at the animation here. So yeah, like a slow walk and then, okay, transitioning and we're fully into walk now. That's pretty cool. We'll talk a lot more about blending using some specific blending options here in the Animator a bit further down the line. But let's just get a quick feel for it now, really intuition based, by playing around with these values. So I can shape these curves, I guess you could call, in this widget. And we can see that what's actually happening is that we're just changing the values in the settings here. So I can spend a lot of time describing what every operation I'm doing has as an effect on the animation here, but I really recommend that you just play around with it. Like, don't worry about breaking anything, just put in any random value here, fiddle around with what you're seeing in the widget, and get a good understanding and grasp of how you are affecting the transition and the animation blending. That's the best way I can put it instead of just boring you by explaining it haphazardly. Let's take a look at this option, has exit time. Now notice my settings are a bit more cleaned up. You can see here in the widget it's much less busy. So I have a much smaller transition time. It's back to the default value of a quarter second. Let's actually just take a look at that. So my is walking here is checked. It needs to be completed at this percentage. So about at 3/4 it will start the transition, which is now quick, and we go into walking. So let's say that I'm playing the game and I'm not doing anything. I'm not touching my controller. I'm not pressing W. My idle animation is going to loop. And now I go into is walking state because I press W, for example. So we see that we're waiting, right? We waited a bit. Let's try again. So I press W, and yeah, I'm waiting until I hit that has exit time value. And I just want to skip that. I don't want to wait. So what can I do? Well, it's pretty simple. I just uncheck has exit time, and there we go. And we still allow for this kind of blending to happen. So let's take a look. I'm going to check is walking. And there's still that transition happening. Now I'm going to blow it up a bit. Let's say 5 seconds once again. Okay. And let's do that one more time. So I'm going to check is walking, and I already started doing my transition. I don't have to wait for a certain percentage of completion of a state to start the transition. So that's really nice when we want quick and snappy movement. We want cancels in a game, if you're familiar with that term. I mean, if you've ever played like a fighting game or character action games such as Devil May Cry or Bayonetta, you want to fluidly and quickly change your animations. Cancel one animation to another animation to perform different moves for that quick and snappy and satisfying kind of combat. So obviously sometimes it's more appropriate to have has exit time than others. And sometimes, well, it shouldn't be on. Sometimes you really want to tweak the blending during the transition to get something that's satisfying to the eye. So you have a lot of parameters to fool around with. And there's no real golden rule I can give you on how to get something that's perfect for your game. You just have to play around with it and find something that when you test it, it feels intuitive. It's giving you the experience you're looking for. Okay, let's keep going. We still have a lot of fun things to do. So let's go from walking to idle now. So I'm going to create a transition again, walking to idle. I'm going to click on this transition and I'm going to call it, let's see, we can call it back to idle. Okay, and this transition, let's add a certain condition to it. So we're going to click here, and we can only go back to idle if is walking is set to false. Now, if we go back here, I'm going to press W, switch to walking quickly. We can really see that it stays stuck in walking because this stays true. Now, if I manually change that, we go back to idle. Now I can press W again. Oops. I'm going to try again. Here's W, okay. And you get the picture. Okay, so let's add some lines of code here to say that once we let go of W, we want to set is walking to false. So it's going to be a pretty similar code. I'm just going to set this to not. So that's one way. Or I can also just get key up. So once we release, so that's the up here, the W key, we can set the is walking parameter to false. And I'm going to add an else here, since on the same update frame, it can't be down and up at the same time. So just doing both of these ifs is pretty useless. So I'm going to add an else here. And let's try this out. Okay, I'm going to press W. And we went back to idle. So that was pretty weird because I just pressed W really quickly and then I let it go. And then the walking animation gets played multiple times and then it stops. So I'm going to try this again. Now I'm going to press it and release it real quickly. Look at this is walking up here. I'm going to press it and let go. If I keep it held down, well, it's going to stay true. But then I'm going to let it go. And then we're going to see we're back to idle. But there's this real weird thing that if I just press it quickly, it plays the walking animation like a few times. And then we go back to idle. So let's see what's up. Well, we can see here that there's some weird things going on. This walking animation gets called multiple times during the transition. So what I have here, let me just put this back to 100%. So there's kind of like a blend of animation going on here. We'll talk about blending animations in much more detail soon enough. But what was happening is, well, actually, let's look at it again. So I'm going to press W. Let's do that one more time. You see that weirdness in the legs? It's kind of merging these two animations, kind of blending them together. So what's happening is that once we press W, we, yes, have no exit time, so we right away go to the walking state. So I'll try do that again. If I press W, we go to walking. But this idle animation doesn't stop playing. It's still going and blending in with the walking. And the time it takes for this to stop playing, we can get multiple walking cycles in it. And once that's done, well, then we just get the pure walk animation happening. So let's try and fix this transition up a bit. So let's put it back to 100%. Bring that back down to 100%. I'm going to move this over here. I'm going to get it down to 0 eventually. There we go. Okay, now let's look at what happens. When I press W, instant switch. So we see that the idle stops. That might be what we want. Now we might want a little blending. So I can bring this in here like that. What does this imply? Well, I press W, let's hold it down. And at the moment I press, it's just like before. So tweaking this to the left didn't actually change anything. But if I bring it to the left and then I change this little knob here, now I get some blending going on. So we can see that the blue actually indicates like the percentage of one animation. So at this point here, where my mouse is at, it's pretty 50-50. So we're blending idle with walking. So let's try this again. So that's pretty cool. What happens if I check has exit time once more? Well, then I have to wait until we get to this part. And I actually gotta keep my Boolean up at true. Okay, so let's just wait. All right, so we have this little section where we blend the animations and then we finally get to the walking state. So I actually kind of like this. without the has exit time. So I press W, and there's like this slow startup because we get that blending. And note that we also have on this walking to idle, we have the has exit time, but it's so quick that doesn't really seem too problematic. So again, I'm going to start, hold it down, and when I let go of W, is walking going to go to false, and the walking animation stops. Well, actually, it completes, and then it blends down to the idle, and then we get back to our idle state. So just to be clear here, while we're blending from walking to idle, we're not in the idle state. So just to see that again, while this transition line happens, or like you can see it here, when we see this line going up, that's the transition happening, and we can get that animation blend. But while the transition is happening, does not imply that we're already at the walking state. So certain behaviors can be really lied to which state we're currently in. So just because we have a bit of the walking animation blending in currently doesn't mean we're at the walking state yet. So just keep that in mind. Here for the back to idle, I'm just going to remove the has exit time. And let's see this. Okay, I'm going to let go of W. Actually, I find this to be just a bit slow. So let's change that. Something like this, maybe. Okay, I like that. I find that responsive, but still aesthetically pleasing. It's really up to you to fiddle around with these transitions and animation blends until you get something you're comfortable with for your application. All right, let's take a good hard look at our code and try and think about how we can make it better. Because when I see this, it just screams beginner Unity code to me. Now, I'm gonna change something here. I'm gonna add a member. I'm gonna call it keycode move, oops, keycode move forward key. So that's gonna be a symbolic name. And this move forward key can logically be pretty much any key code. So it could be the W key code, it could be the up arrow key on a keyboard, it could also be buttons on a joystick, or anything else really that's a value available in the key code enumeration. And I'm going to just switch this keycode.w that's hard-coded to move forward key. Now this is really good because let's say I want to have a two-player game. One person's controlling the Xbot and the other one the Michelle character. I want this same script to be on both of the game objects. So I don't want one specific animation test script for the first player and then the second one that's pretty much the same but just slightly different to change the hard-coded key. I want one script that's modular enough that I can adapt it. Actually, I don't need to adapt it for each specific game object. It will work on any one that I plug it onto. So we get this really nice versatile component. Now, the thing is, this value, well, what is it? We don't really know what it is, so I can't remember what the default value for this key code enumeration is. It might just be the first one in the enumeration. So let's actually make this public. Let's allow the developer, not the player, but the developer, to go into the inspector of this component and select what they want. So here I already set it up to W, player, and on Michelle I did add the animation test script and I selected the up arrow. So they both have the same component, but you get to select which key each one uses. So just to show you, you can actually select any value from that enumeration here with the drop-down list. It's pretty practical. Now, I don't know if you guys use public here for when you want to make initial state visible to the inspector. maybe you use serialized field. And this is what I actually promote. This is what I use with my undergrad students at the University of Sherbrooke, and this is also what I use when I teach my Unity courses at CEGEP level. And I haven't had anybody tell me to do otherwise for now. And I also saw that a lot of these advanced developers also use this. I know that a couple game companies in Montreal also use serialized field. So Ludia, for example, that switched their internal game engine to using Unity now. So all their new games uses Unity. This is what they use as well. They use the serialized field. And it still allows us to have the field visible in the inspector for modification, but it is private, right? So I can actually write that here. It's private, meaning that client code can come and select this attribute, this member, and start modifying it willy-nilly as they want. So we still have encapsulation, but in the editor, we get to modify it. So we kind of get a best of both worlds aspect here. So let's take this new code out for a spin. I'm going to press W. So I got my player 1 walking, my Xbot. And I'm going to hold this W down and I'm going to press the up. So I got Michelle walking. I'm going to release W. Whoops. I actually did something quite wrong here. What did I do? I have get key down on both for some reason. That's weird. Okay, let me fix that. Get key up. Let's try this one more time. Okay, so up, let it go. How about W? Same problem. I think my code here did not save. Oh, actually, they're both setting it to true. So I don't know what happened with my code, but it should be fixed now. Okay, there we go. All right, that's much better. So speaking about the code, we're actually not done with our optimizations. There's still a few problems. I want to get back to that problem I discussed about having hard-coded strings in here. So recall I said that let's say somebody goes into the Animator, like a game designer or just an animator, comes in here and changes is walking to, let's say, is walk. Then we gotta go back into our old code and change this here and then change another line here again. Every time we go back into our code, we're risking breaking things. We're risking to create another disaster at launch time. So we don't want to create another Cyberpunk, unfortunately. We don't want a game-breaking game. So let's try and avoid hard-coded strings as much as possible. Now, we're going to use the different flavor of the setBool function. So one takes a string as first parameter, but the other overload for this function can actually use an int. So I'm just going to go back and put is walking. And I'm not going to do that manually. I'm actually going to use writer here to help me out to change this setBool function to its other variant. Now, we can see that writer is giving me a message, and I don't believe that Visual Studio gives us such a message. It says string-based property lookup is inefficient. There's actually a forum post on the Unity forums about that. So this person here is claiming that using the int ID instead of the string ID version is about twice as fast. This person doesn't give their code, their exact methods, so take these statistics with a grain of salt. A lot of people like to really claim better performance, but it's very specific to their use case. And once you start, looking into the numbers and making sure that everything is done correctly, you start to question that their claim was actually untrue. But I mean, people here are saying that, okay, seems good and whatnot. But more importantly, writer itself, which is pretty reputable, is telling us, hey, look, this is not the way to go if you're looking for something optimal. And this code is in our update. Now, we're not calling this at each frame. We're only calling it when we get key down on the move forward key or key up on the move forward key. But that can still potentially be a lot of calls in the long term, especially when we're playing the game for a couple hours. So, I mean, why continuously call this inefficient method when there's something potentially better? And we can just simply click here, and writer, yes, it underlines the problem, but it's kind enough to give us a solution. So I can click here again and click on this, and we can see that we got this line 13 created. And I will admit it's a pretty intimidating line. But let's just do a quick test to make sure that nothing's broken. Okay, up arrow key, great. And now W. Okay, cool. So everything is still functional. It's just that now things are more optimal. Now this line can seem pretty intimidating to somebody who doesn't know a lot of C#. We know what private is, we know what static is, but what's this read-only thing about? We knew what an int is, okay? And what's this animator.string2hash is walking? So let's break this up. I'm going to just change read-only with const in my attempt to explain what read-only actually is, because most of you should be familiar with const. So I'm putting const here and we're getting some red lines, and let's talk about them. First of all, const is not the same const as the one in C and C++. So you know what, as I said, a const is in those languages, but in C#, a const is by default static. So that's why we get this red line here, okay? So we have eliminated one red line because having static const in C# is just redundant, since const is necessarily static in this language, unlike C and C++. And here on the right, well, we're still getting this problem. So what's up? I'm declaring a constant that's private, and I'm affecting it or defining it at the moment of declaration. So that should be okay, but it isn't. So what does the IDE have to tell us? Constant initializer must be compile time constant. Okay, so this expression here is not evaluated at compile time. But when we have a const in C#, it needs to be declared and defined at compile time. So in our application, in our context, this needs to be defined before the game runs. But this function is called during the execution. So it's dynamic and not static. It's not at compile time, it's during runtime. So this does not work. If we want to declare runtime constants, that's when we get read-only. So that's one of the nuances between const and read-only. There are others, but for now, let's just focus on that. However, it's not static by default, so I'm just going to add static here. Static is not necessary, but it's just a smarter use of our resources here. So I'm also going to change this to Pascal case. Okay. And why is static more performant? Well, it's better for our use of memory. Now, let's say that I had this component on 10 different characters. Well, we don't need to go call this function 10 different times for each one. So for each instance of animation test, we don't need to call this function during runtime. We only need it once. And this function, what it does is that it will go get the ID based on the string. So let's go here. All right. So isWalking is the string symbolic name for this parameter. But like, let's say under the hood, it has an ID. And that ID is the same for every animator. So for the player one and the Michelle one. So we're taking this isWalking string and just changing it to an ID, which is actually the hash. So there's a hash table or a hash map or dictionary behind the scenes going on. So let's say, just for simplicity, this returns the hash 0. So we're saying that isWalking is equal to 0. So I'm just going to update this to my isWalking, well, the capital I. Okay. So let's say it's 0, we're giving it ID 0. That's saying to set the parameter at ID 0 for this specific animator to true. So let's say we're talking about this animation test component on the player. It's going to go get this animator, which will refer to this variable here, isWalking. And again, this is the local isWalking variable for this specific animator on this specific player game object. So this line ends up setting this to true, but it won't set Michelle's one to true. In the Michelle game object, we have this animation test again. It's still going to have this isWalking equal to 0, but when we set bool 0 to true, it's not going to go get the player's isWalking variable. It's going to get Michelle's isWalking variable and set it to true. Now, we see that in both cases, the hash that refers to the local copies of isWalking is the same. So we only need to, let's say, evaluate that once, so we make it static. So basically, all instances of animation test will have the same string hash for the isWalking parameter. Instead of calculating it like tens or thousands of times to always return the same exact hash. That's just wasteful. So that's why static is preferable here. All right, so let's get our characters moving now, shall we? Because it's starting to get quite dull. So I'm going to create this function called move forward. And let's say that it's like an action, it's a command. So this action will be, well, pretty self-explanatory. We want to take the game object that contains an animation test component and, well, move it forward as the function name implies. So to do so, I'm just going to get a reference to the transform, the game object. I'm going to use the translate method, and I'm just going to move it forward. So I'm going to move it like so. So let's say I'm going to look at the player and I want to move it forward. So remember that forward refers to this blue vector here, this blue axis. So moving it forward would be like this. Moving it backwards would be moving it like this. And we want to use the local orientation of the game object. So let's say if I turn it like this, and now I tell it to move forward, well, we're going to move like this. So always along this blue Z positive axis. Okay, so just keeping it simple for now. We can come back later and make this code a bit better. I'm going to take vector 3 dot forward. So that's just a shorthand for 001 vector. And I'm going to be really explicit here and say I want to move in local space. So that's space.self here as a second parameter. I'm going to save that. And, well, we can see this is grayed out because this function is never called. So let's change that a bit. So in our update, let's say that if we have the key down on W, we want to move forward. So I'm going to call the move forward function. And this, well, it might look good. So let's try it out, but it won't really work as you might expect. So let's just get some space here because things are getting cluttered. Okay. So I'm going to press the up key, and okay, cool. We saw some teleportation happen there. Let's try W. Okay, so our player went from 0, 0. I think it wasn't at 0, 0, 0. It's probably like at 0 0.05. Let's just try that again. Yeah, our player is not at the correct position. I'm just going to change that. Okay. Try this again. So I'm going to press W. All right. So yeah, I still have it held down. You can see that is walking is still true, but we're not moving forward anymore. That's because get key down is only is only true once we press the key down, but not while we hold it down. So how do we fix that? Well, I'm going to do the following. I'm going to create this private bool. How should I call this? I'm going to call this move forward key pressed. And we're going to start it out as false. Now, once we press down on the key, we're going to set it to true. So move forward key pressed equals true. And actually, I'm just going to move this into my... Oh no, I'm going to keep it here. Sorry for the slight confusion. Okay, I'm going to remove the move forward. And in this if, I'm going to set that Boolean to false. Okay. And now an update. I'm going to add another if. Here I'm missing an else actually. Just noticed that. Okay. Here I'm going to have an if, and I'm going to write if move forward key pressed. So if this is true, I'm going to move forward. So at each update, I'm going to check the state of the move forward key, and if it's pressed, I'm going to move forward. So let's try that out. So that's way too fast. And here again, it's way too fast, but we can see that it's working. Now, why is this way too fast? Well, by default, Unity runs at 60 frames per second. So I'm getting about 60 updates per second. Not exactly, because, well, things can't be exact. This isn't a very exact, precise machine. We're talking about computer science here, so we're always working with certain imperfections. But it's about 60 frames per second. Now, if the game dipped in FPS because, I don't know, we had a bunch of particle effects all of a sudden, well, we might be moving more slowly. So let's say our FPS dips down to 30 for an entire second. Well, then we'll do half the distance that we just covered now in a second. So you probably already know where I'm going with this. We have to scale our displacements with the time, specifically time.delta time, which is the time it took between the previous frame and the current frame. So let's say that in between frame 0 and frame 1, it took about 16 milliseconds. And between frame 1 and frame 2, we needed, I don't know, 50 milliseconds. Well, this time by delta time will be bigger for in between frame 1 and frame 2 than in between frame 0 and frame 1. So the displacement done will be bigger to compensate for that, that dip in FPS. Again, this is just a real quick review of something you most likely saw back in the previous course. Okay, so let's try this out one more time. So now what I'm expecting here is to have a displacement of 1 unit per second. So I should say a speed of 1 unit per second, sorry. Now, remember this is 001. I can actually say 1 meter per second because that's the standard, that's the convention. So 1 unity unit should be equal to 1 meter. So now I'm going to hold this, and hey, that's not bad. Quite a nice strut we got going. So now we're advancing at 1 meter per second. Here also. So we don't really get that gliding effect. I mean, it's still there. It's not perfect. Our speed is uniform, so our displacement is linear, but it's still pretty convincing. Now, if we make our speed faster, let's say I add a serialized field here, private float move speed. Let's say I set that to, I don't know, 2. And I just multiply this vector by that new variable. So that's move speed. I'm going to save this. I'm going to go back here. Now it's twice as fast. And we do see that gliding effect a bit more. We can make it really pronounced by going here, right? I made this a serialized field, so I can change it. By default, it's set to 2. Let's actually just keep that at 1. That might be more appropriate. But I can come here and then change it to anything I want. So let's make it 22 for the player, and let's make it like 0.01 for Michelle. So Michelle is advancing, but incredibly slowly. You can see here it's Z local position changing. And here, well, this is much faster. Let's do that again. We'll see, yeah, not quite nice. And here as well, we can really see that for the amount of steps she's doing, she really isn't advancing all that much. So we have some dissonance between what we're seeing in terms of the animation and what we're getting as displacement. So I'll keep things back at 1 because that wasn't that bad at all. Okay. And well, one more thing. So this is something I like about Rider again. Order of multiplication operations is inefficient. So this is some real cool stuff to be told by Rider. So what's the problem here? Well, as you might already know, here I have a vector object multiplied by a float. So I have a vector times a scalar. So just a simple operation here. But this gives me a new vector. And then I take that new vector and I multiply it by another scalar to get another new vector. So I like create this intermediate vector here in my data. And that's really inefficient because it needs to be garbage collected eventually. Or actually, no, it's not going to be garbage collected because this is going to be allocated on the stack because vectors are structs and not classes. But still, we're creating a temporary vector here that's really unnecessary. So again, we're doing vector times scalar, that gives a vector, and then that resulting vector, we're multiplying it by a scalar to get our final vector. That's not really cool. Why not just multiply these two scalars together to get one float and then just do one vector times float operation? And that red line now disappeared. And why not, let's make this a one-liner like that. Okay, and I'm just going to do some quick cleanup here because things are not consistent. I'm just going to put it like this, and put this here, and put this here. Okay, so I'm just putting my static things up on top, then my serialized fields, and then my pure private fields right after. As an exercise, add transitions from walking to running and running to walking. To do so, create a parameter here that's called isRunning, and in code, add what's necessary to press a key to go into a running animation. For example, if I hold left shift for the player, well then I can go from walking to running and my movement speed can increase. So try that out. If you can't, don't worry, I'll show the solutions soon enough. So work on that. Once you're done, resume this video and I'll show you what I did. Let's have a look at the animator for this exercise. Now I've added these two transitions, one start running and the other back to walking. So you can look at my parameters here for back to walking if you're interested. And here it is for start running. Okay, now do I have any conditions? Yes. So I have this isRunning Boolean parameter. It needs to be true to go from walking to running. And for this one, well, you probably saw it coming, isRunning needs to be false to go back into the walking state. And I've added this parameter isRunning right here. Let's have a look at my results. So W, and now if I hold W, then left shift in my case, I start running, let go of shift, keeps walking, let go of W. Let's do a few more tests. Just shift. Shift by itself does not put me in the running state. Okay, W, let go of W, shift again, does not work. So I need to be walking to be able to set my running Boolean isRunning to true. And when that goes true, I should have faster movement speed as well. So now let's take a look at the code that allows all of this. Let's have a look at the code behind this. So as you can notice on line 9, I've added this line to go get the hash for isRunning. Also notice how I just renamed things here to be a bit more appropriate. Before this was called isWalking, which is not a good name. So as programmers, we expect the value type of anything called is something to be of type Boolean. But it's really an int, so this is a better name. Walking param hash and then running param hash. Now I've added this key code for a run key. In the example, I'm using left shift. As you can see here, run key is left shift. And also let's note that I've added a run speed. So this run speed is here. Set to 3 by default, but we can also change it in the inspector through the editor. So this was here before, we still have move speed, and now we have two booleans. One is moving, that will track the state of our character in terms of is it walking or is it running. So if we are walking or running, this should be set to true, and we can use this boolean to control flow within this code. Then we have is running to know if the character is running specifically. Awake stays the same. Now this update function is getting a bit heavy. We'll talk about that soon, but let's carry on for now. This entire section is dedicated to just getting our character to move. So if we press down on the move forward key, we tell our animator, okay, to set is walking to true, and then we set our internal boolean here is moving to true. If we haven't pressed down on the key, but rather we have let go of the key, so else if here, well, we do the inverse operation. Instead of setting things to true, we set them to false. Now, I don't recall if I've said something about this else here, but it's pretty good for optimization. The code will still function without the else, but sometimes, let's say you are pressing down, so you just press down on this key. You're obviously not in the same frame letting it go. So these two things, logically, cannot be true. These two conditions cannot be true in the same update. So if this one is true, there's no reason to evaluate this. I shouldn't even take the time in my schedule to figure out what this returns. So I'm just going to put else. Okay. Now we have something similar here. However, note that this is about the run key, and I have this extra condition. So if I press, let's say, left shift for my run key, I shouldn't be able to go into my running animation and setting is running to true, and also modifying my move speed to the run speed if I'm not already moving. So I don't want to be able to go from idle to the running animation but not be moving. That sounds pretty nonsensical. So I have to make sure that I am moving. In other words, to be able to run, I need to be pressing the W key in this specific case. And here we have the else if. So if I let it go and we are running, then we set our is running to false and everything else to false, and we put our move speed back to the walk speed. And here we still have the actually move the game object. Let's take a few seconds to talk about this big and ugly update function. Say, for example, we want to add a jump action, a crouch action, a shoot action, kick, punch, and a bunch of different actions. Now, these actions may or may not be attached to animations, but whether they are or not, we still end up adding like these kind of paragraphs for each action. And that becomes really unwieldy when we have a bunch of action. Just imagine the scale of this update function. Then imagine somebody new coming into your project, opening the script up, and seeing hundreds of lines of code. It's pretty intimidating. And it's also just not aesthetically pleasing, in my opinion. So when I start seeing things like this, I already tell myself that, yeah, there's something to be changed. So we can start dividing this function into smaller functions, first of all, to make it a lot more accessible and just easier to follow. But there's also another problem. Here we have, like, let's say the body of each if is the action. Well, each action is very tightly coupled with the inputs. So for now, we can only like walk our character through physical user input. That's really bad, especially when we want to test our game in a reproducible manner. So we should be able to control the character, perform these actions, like this one or this one, automatically. So we should decouple these actions from the process of getting keyboard input. Now this allows us to perform unit tests. So I could just like in video game demos back, in the good old days, I guess you could say, when you didn't touch the controller and a game demo would start. Those weren't pre-recorded videos, of course not. There wasn't enough space on the NES or Super NES to just record videos and have them play in the beginning. It was the actual game, just that the commands were not passed through user input. The commands to the player characters and enemy characters were passed automatically through some sort of test per se. So when you're doing unit testing, for example, you want to be able to perform the same tests every time you run the suite of tests. And by same tests, I mean if you're testing your walking character, let's say you want to make it walk for 3 seconds, it shouldn't be up to the developer to actually hold down the W key for 3 seconds, because we're not getting consistent testing. So maybe you'll keep it down for 3.1 second, and in another test you'll get it down for 2.9 seconds. And it's really important to have rigorous and consistent testing, because if you don't do that, well, every time you add a new feature and you don't test your previous features, you're risking that this new feature might break your previous features. You're risking that your expansion or your DLC might ruin previous functionality in your game if you're not running tests every time you come up with a new build. So all this is just for your personal culture per se, and to get a better understanding of better practices just in programming in general, where we want to decouple, input from action. And decoupling and modularity are always a big, subject in computer science just in general. That being said, I won't take the time to make this, let's say, better. I won't take the time to make this more modular, more maintainable, more extensible and whatnot in the future. I've already spoken enough about this, and I don't want this to turn into an advanced programming course anyways. That's not the purpose. But I still thought it was important for you guys to just think about that for your games in the future.